Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is video for modems. And as you take a look at the whiteboard here and just an overview of some of the topics we're going to look at here, I'm going to be right up front with you about this section. There's a good deal of memorization here required for the exam on the basics, on the pins, that kind of thing. And that's strictly theory. You know, we'll make it as interesting as we can here, but some of this material you're simply going to have to memorize. It's a little hard to get into the modem cable and look at the pins and that kind of thing. Nothing particularly difficult, but it's a good idea to have this information in mind the day you take the exam. Also, we'll be calling up an access server on the pod that we've been using throughout the course. An access server is a Cisco router that allows you to connect to multiple devices behind it, so to speak, simply by connecting to it either directly, physically, or via telnet, or actually via dial-up, which we'll talk about a bit here. So later on in the video, when we're looking at IP host tables, reverse telnet, we'll talk about the theory, and then we'll see how they actually work on a Cisco access server. And, you know, modems aren't gone yet. With all the high-speed connection methods that we have today, it's easy to forget that the good old modem is still a valid way to connect to a Cisco router via dial-up. And many of today's networks still use modems to do that, especially as a backup method. And it's important for the exam and your work to understand how to configure a modem. And that's the other thing I want to talk about before we go into the modem basics. Again, talking about modems today is a lot like talking about design. I could sit here and give you a design lecture for 30 minutes and it would have nothing to do with your network. And the challenge with modems is pretty much the same in that it really depends on what model of modem you purchase. So I know we always say, hey, you know, read the documentation. And you get that new modem out and you look at it and you read the documentation for about 2 minutes and you say, I know how to put a modem in. And then 3 hours later, you're still trying to figure out why auto configuration isn't working. Having been there, I'm telling you, you got to read the documentation with today's modems. They'll save you a lot of time and a lot of trouble. So let's talk about those basics when it comes to modems anyway, and you know what a modem does. And what modem stands for to begin with, just in case you didn't know, is modulator demodulator. And the modulation comes in when the modem changes the computer's digital signal into analog signals. And of course, that's that sound we always hear when we make a dial-up connection. And the demodulation is on the other end when the analog signal is changed back into a digital signal so the computer on the other end will understand what's going on. The good news is you don't need any special lines. You really don't need any special equipment on the customer side. But the bad news is the data transfer speed is going to be pretty low. I know you're familiar with the terms DTE and DCE. I just want to remind you of a couple of things here, because we tend to just think about, you know, the frame relay stuff, you know, the frame relay switches being a DCE, the routers being a DTE. For the purposes of our conversation here, DTEs are routers, but they're also PCs, workstations, and mainframes. Those are DTEs. And the DCEs not only include CSU, DSUs, of course, but the modems themselves. And the physical standard defining the connection between a DTE and a DCE is EIA TIA 232. Anybody who's worked with modems before knows that one by heart. And if you have worked with modems before, a lot of this will seem familiar to you. You'll have a good leg up here. This is the cabling that I was mentioning to you, and typically a DB25 cable is going to be used for a DTE DCE connection. But only 8 of the pins are really going to be in use. And the data transfer pins are shown there on the whiteboard. We have 3 of them, pins 2, 3, and 7. It's a very good idea to know what those 3 pins are and what each one of them does. And the transmit data, the DTE uses that to send the data to the DCE. and the received data, the DCE uses this to send data to the DTE, much like what we have here with two modems and a telephone company in the middle, which we got to have. When the DTE sends the data, it's on pin 2, the TXD pin, and on the other side, when the modem is sending the data to the DTE, it's sent on pin 3, the RXD. You will also see those referred to simply as TD and RD, leaving the X out. We also have pin 7 there. That's simply our grounding pin. It's a reference point for other signals. 3 modem control pins you should know. Pin 6, data set ready, means the DCE is ready. The 8 pin, carrier detect, and the DCE is detecting the carrier signal with the remote DCE. And then finally pin 20 is data terminal ready, and that is the DTE telling the DCE I'm available for a call. Finally, 2 more pins you should know about, the hardware flow control pins. Pin 4 is request to send. It's the RTS pin. That is the DTE having buffer space available and requesting that the DCE send it more data. Clear to send is pin 5. That's the DCE saying I've got buffer space available. I'm requesting to the DTE to send more data. So again, it's a good idea. You might want to pause the video on each one of these and just take a look at them. Unfortunately, it's not really something I can give you a lab on to do to reinforce. Just occasionally, we just have to memorize these things. These signals can also be used when either the DTE or the DCE wants to terminate the connection. A DTE can simply drop the data terminal ready signal, which if you don't have that, you don't have anything else, so the connection will be terminated. And if the DCE sees that the carrier detect signal is either low or non-existent, it will drop the connection as a result. Physically connecting the modem to the router. Now in production networks and in home networks as well, again, I would not rush out and buy a modem to add to my lab for this particular exam. If you want to, fantastic, but it's certainly not necessary. In production networks, you're going to see a modem connected generally to an async interface or the auxiliary port. However, a modem can be connected to the console port, which is not a good idea, or a serial interface, which is also, to me, not a good idea. But I'm going to tell you how to do it anyway so you know. On the auxiliary port, you're going to use a rolled cable, and you will need an RJ45DB25 modem adapter. You will connect that adapter to the EIA-TIA-232 interface, then the rolled cable to the adapter, of course, and the other end of the rolled cable to the aux port. Now, the aux port is right next to the console port on the router, on the back. And everybody's been there, and I've done it myself, where you plug the cable to the wrong port. So again, I want to urge you to get in the habit. When you're troubleshooting, start at the physical layer. Because again, I'll tell a story on myself. I've done it. I've sat there for a few seconds, and I meant to put the roll cable into the console port. I was going to configure a router. And I put it in the auxiliary port, and all of a sudden I'm being asked for a password. And I said, who in the world, and that's not exactly what I said, but it's real close, I said, who in the world set a password on this port? You know, I can't get in, I know the password, blah, blah, blah. And then a couple of minutes later, frankly, I looked over and realized, oh, I put it in the wrong port. So once I put it in the console port, it was fine. So if you have a problem connecting a modem to a router, make sure you have the cable in the auxiliary port, because they're both RJ45 ports, the console port and the auxiliary port. They look exactly the same. They're real small, and they're right next to each other on the router. So moving on, if you want to have a serial interface act as an asynchronous interface for modem connectivity, you can try to use the physical layer async command. And I say try. I'm giving you the book theory there. In the real world, that does not always work, and you'll need to check your router documentation, because not all serial interfaces will accept that config. I know that the ones in my pod will not, or I would show you. But theoretically, it is there for you. Physical layer async. Now, the console port, you're very rarely going to see a modem connected to a console port because it's really not built for that. It's not built for modem usage, and you're going to have problems, inherent problems, using the port for modem connections if you are connecting to a router via a roll cable and a modem. You really should be using the auxiliary port. Cisco will tell you the same thing. I think you can find some documentation out on their website about using the console port for modems, but I've tried it. It really does not work particularly well. Now, I want to bring this up because this drives me nuts when I see router documentation. I've seen one piece of Cisco documentation say, well, you know, one advantage is that if you have a modem connected to the console port, you can do Cisco password recovery remotely. Hey, that sounds like a great idea, right? Well, you can, but you still have to have someone present at the router to perform that operation. The documentation you read out there tends to make it sound like you can use some magic keystroke to do that password recovery remotely, but you can't. You're still going to have somebody there to do some of the operation. So don't fall for that. I don't think that's going to be an exam question, anything like that. But I would watch that. It's true, but you still have to have somebody present at the router to make it happen. Connecting two DTEs directly, no problem there. A null modem cable makes that possible because pins 2 and 3 are crossed. So that allows us to connect two DTEs directly because the pins 2 and 3 are crossed. Remember the TXD and the RXD? If they're crossed, you can use that cross cable. It's not a crossover cable. It's a null modem cable, and you can use that to connect two DTEs directly. Now we're going to get to one of my favorite subjects, actually a little more interesting than the theory we've had to talk about here, and this is reverse telnet. And for those of you who do have your own home labs, if you have an access server or if you've rented rack time from an online provider, you've probably used reverse telnet and not even known it. But if you're like me, the first time I heard this term, I thought, well, how do you reverse the telnet process? I mean, does the router connect to you? Think of it this way. When you're using regular telnet, it's kind of like this. You are accepting a connection into a line. That's what you're creating. It is a forward connection. But when reverse telnet is in use, a telnet session is being initiated out an asynchronous line. And we're going to take a look at that and how it's configured in just a moment on a live Cisco Access server. Matter of fact, let's call that up here right now. And what we actually want is the AS. This is an access server, the one with Bryant Advantage 166 as a prompt. And what this does, you can telnet to this, and we could set it up for dial-up, we could set it up for telnet, we can set it up for anything we want, really. And by doing that, we could have multiple users dial in. Let's say we have some remote telecommuters, and they're just at a different place every night, but they need to dial back into the office at night. And we could set up an access server to make that happen. And for us in the home lab, there are actually routers behind this access server, so to speak. Let me show you a little bit of a drawing here about what we're talking about. This is what I'm talking about. We're going to come back to this later about checking the lines, but I want to give you a visual of what we're talking about right now with reverse telnet. In that you as a user would connect to the AS, the access server, and there are 5 devices behind that, all connected on a different asynchronous line, and I've numbered the lines 1 through 5. And that's how we've been getting to routers 1, 2, 3, and switch 1 and switch 2 throughout this course, is by reverse telnet sessions. So let's take a look at the actual configuration that we've got on this router. And you're going to see an IP host table there. We're going to come back to that and talk about that in just a few minutes. Well, what happens here, you see that we've got lines 1 through 11 and then line 12. We've got some sample configurations on. And what we're really looking at here are lines 1 through 11. And I configured those as a group. But no exec is a command that prevents a rogue exec session from tying up the line. And transport input all, we're going to talk about that shortly. But this is part of a reverse telnet session that we have configured these lines in advance to let users connect to it and use these lines. And then, to really make it happen, we have this IP host table. And I get asked about this sometimes with people who are looking around on my rack rentals and they look at the access server and they say, well, what's this IP host thing? Well, this actually makes reverse telnet a little easier. And it's the IP host table that we're using. And going across, this is a local DNS resolution, really. Remember, when we type something in that is not an iOS command, the router attempts to resolve it locally first for DNS. And that's what the IP host table does. But then we've got, instead of just an IP address, we have some numbers, 2001, 2002, and so on. Well, the TCP base port for the individual lines is 2000. So if you just add the line number to 2000, that tells you what number you've got to use right there. So since we have line 1 connected to router 1, then it's 2001 and so forth. I have line 5 going into device SW2, so the number is 2005. And what you've got to do is kind of anchor that, because you see the IP address is the same for all of them. Well, that's just an interface on this access server itself. That's all it is. Usually it's a loopback. That's what I like to use. But that's what makes reverse telnet possible. And again, you may have used it without even knowing about it. And what we're going to do right now, let's try the number 4. Okay, 4 is not an open connection, but I bet 1 is. 1 is because what we just did is we resumed a reverse telnet session, because you can suspend a reverse telnet session once it's opened, and you suspend it with Control-Shift-6 and then followed by an X. That's the fifth line down, actually, to suspend reverse telnet. Because when I have users come in, I give them a handbook, via email and say, here's how you navigate the pod. And they look at this and go, Control-Shift-6X, what in the world is that? You're suspending a reverse telnet session. Because notice when I go from router 1 back to the router prompt there, I just did Control-Shift-6X. But I have only opened a few of these reverse telnet sessions. So line 4 is busy right now. We're going to clear line 4. If you get a hung session and you're using the IP host name and you just can't get in, you possibly need to clear the line. And see, just by typing SW1, I got to switch 1, and you can see the line number right here. I just opened a reverse telnet session. So now if I want to suspend it and go back to the access server, I do Control-Shift-6X. Now, yep, that's going to happen sometimes. That line's tied up. So that's how you do it. Now if you want to terminate a session, which we're going to do shortly, you would actually just type disconnect right here at the router prompt. But that's all reverse telnet is. That's really all there is to it. And we saw the IP host table, and you see now where all that comes in. Instead of having to configure any kind of telnet session, I used reverse telnet, typed SW1. You could see the router went out to resolve it, and it looked in the IP host table first, found it, and then opened the session for me, and there I am on the device. So it's just that simple. And let's minimize that window, and we're going to move on right now to modem standards. And it's a good idea to know the standards that I put here on the whiteboard for you. And having worked with modems quite a bit in one of my networking jobs, I can tell you from experience that the hardest part of the entire process is finding modems that play nicely together. You know that Cisco likes to have Cisco proprietary versions of some technologies. They have their own version of HDLC. Of course, we have Cisco Discovery Protocol, that's Cisco proprietary. But they at least usually have a non-proprietary version of the same technology. But I'm telling you right now, modem manufacturers don't operate that way. They'll just say, well, you know, you can't use this with modem X or Y or Z. So you really want to take the time to research the compatibility of any new modem you're going to buy with your current network's modems before you spend your money. I've got some standards on here. A couple of them are a little old. You know, hopefully we don't have too many 14.4 modems in our networks. But V32BIS, V34, V90 there, I've got 56K transmit and 33.6 receiving, and of course this is kilobits per second. V92 transmits at 56K, receives at 48K. A couple of other features with V92 is that it's got a quick connect feature that is supposed to reduce your client-server negotiation time by as much as 30%. Also, modem on hold enables a remote dial-in user to suspend an active modem session in order to place an outgoing call or accept an incoming call, and then when that phone call is completed, the initial modem session is actually rejoined. Now that's pretty cool. Quick connect, I have not noticed any huge difference in time, but modem on hold, that's a good deal, especially for your end users. They love that. You're going to check those lines now, and again I wanted to show you this so you will see what we're looking at. We'll have 5 lines on our router that are busy. And the main command that you're going to use to monitor and troubleshoot modem and access server connections is show line, and we're going to run that on our live access server here in a moment. But I want to remind you, you as a CCNP candidate, you're familiar with an access server the way that I've been describing it, as a central home lab device. Obviously that's not their only use, but really any router that allows dial-in is technically an access server. If you go out to eBay and take a look and just do a search on access server, you'll see a lot of access servers. So we're going to use the command show line to get our general information, and I have a lot more lines on this. Actually, I'll just show you. I've got 52 total lines on this particular router, but we don't need to look at all of those. Now the column headings here for the most part are pretty vague, so we're going to take a look to discuss what they mean going from left to right up here. Now we've got TTY over here, and that's actually the line number itself. And you'll see these asterisks over here from 0 through 5, and that indicates that that line is currently in use. So if you're trying to connect to a line from here or trying to look at a line, you see that asterisk, it is in use. Now TYP, as you can probably guess, is the type of line, and we've got a couple of different kinds here. We have CTY here right off the bat, line 0. That is the console port. Lines 1 through 16 on this one are TTY lines. These are asynchronous lines that are used on access servers to connect to other devices. And we know in our example here, 1 through 5, those are connected to actual other routing devices. Line 17, AUX, that is our auxiliary port. And 18 through 22 here are VTY lines, and I know that those are used for telnet connections. So we can tell right now that the console port is in use, that lines 1 through 5 are in use, and line 18 is in use actually by me because I'm telnetted into this particular access server. I'm not directly connected to it. So let's go from left to right at the top here and look at what a couple of these mean. TXRX, I'm sure you know, that's transmission and receiving capability of that particular port. The letter A here actually stands for autobaud. for modems. And if Autobaud is configured for a line, then you will see the letter F here. You think it's the A, but you see F. If not, then you'll see the hyphen that you see on all of the ones here. Modem indicates the modem signal type configured for a line. And if you are really hardcore and you've got access lists configured on your lines, you'll see the numbers show up right here. That is not something that I have ever done, but you can theoretically do it. Uses, actually I've put one on telnet lines before, so you would see them on the VTY lines, but not on the modem lines. Uses indicates the total number of connections, both inbound and outbound, that have been established. And you can see here we've got quite a few uses here. Line 6 here actually goes to the frame relay switch in this pod. And that's why you don't see it open right now, because I don't configure that during this course. And there's a little bit of gibberish in that line, I bet, because that's why we see 125 with noise. That's how many times noise has been experienced on this line. And 125 is a little high. You can see we've got 0, 1, 3, 0, 0, 0 here. That's one time we'd rather have zeros. And let's see, you can see down here the telnet line. I've hit that one 51 times. And I've hit line 19 7 times when I was telnetted into it twice. And what we can do, let's look at the detailed information for one of these lines, and we're gonna pick line 18 since that's the line we're telnetted in, and we can do that with show line 18 or whatever that number is, and I'm gonna tell you point blank, there's probably more information here than you would ever want to know. You could see the information here that we had already looked at, the uses and that kind of thing. You can see the baud rate. You can see the status, capabilities, whether a modem would be ready to go on there. That's of the port, by the way. It does not mean that a modem is on this line and ready to go. And you see some timeouts here. We had an idle exec for 10 minutes, so we timed out. Modem type is unknown because there's nothing on there. This is pretty cool too. You can actually see how long somebody's been telnetted in. I've been on the line for an hour, 33 minutes, and 36 seconds, just in case you wanted to know. And that's really about it here. And again, getting back to modems, unless you work on them a great deal, you may never even run this command. But it's still a good one to know. So we got to see those live, and you saw us checking the line status there a couple of times. That's a command I want to toss in here if you work with a lot of asynchronous interfaces. You don't want to spend your time entering the same command 10 times. And you know the range command, if you've taken the BSCI, but if you've taken the CCNP switching exam, you know how to group all the interfaces together with one command. So if you type speed auto, then you don't have to do it 24 times or 48 times, you just have to do it once. Well, if you want the range command for asynchronous interfaces, you would use interface group async first and then give it a number, whatever number you want to give it. Then type group range underneath that, and then just whatever range of lines you want to have as that interface. And then if you want to apply one command to it, you just type it under interface group async 2, and whatever you type there will be applied to all of those lines. That's a time saver. We don't do that too often, but when we're setting up a switch, you've got 48 ports, and if you want to change something, you don't want to type it 48 times and have to keep going into, fast interface 01, fast interface 02. Those range commands can be very helpful. We're going to talk about an initialization string here shortly, but for right now, we're going to go back to the access server and look at some choices for basic modem configuration as far as the router is concerned. And again, I want to remind you, working with modems, it's a lot like working with network design. There is no one configuration fits all solution, but we're going to take a look at some of the more common router configuration commands here that'll help you get started with modems. They will help you pass the exam, but this is certainly not a complete list of modem router configuration commands. So there is your disclaimer. The basic configuration starts much like the VTY config to allow users to telnet in. And here we will assign line 16 in config mode. Remember how we did line 04 in the past for Telnet? We're just going to pick line 16 here. And you could just put login, just like we have before, and assign a password. And that would be it. You know, that part's pretty simple. And when it comes to flow control, you know, we talked about hardware flow control a little bit earlier. And I believe we're going to see 3 choices for that. Let's see what happens when we try to set flow control. I was just trying to figure out why that was an unrecognized command. See, mistyping happens to all of us. For flow control, we've got 3 choices, you know, none, hardware, and software. And the recommended selection here by Cisco is indeed hardware flow control. And that's also known as CTS-RTS flow control in reference to the pins used in this particular version. The use of software flow control, which is also called in some documentation X-on, X-off flow control, it is not recommended by Cisco, and it's not recommended by many modem vendors because it really tends to slow data transmission down. It sends a lot of start and stop bits, and the reason software flow control is also called X-on, X-off, that's the actual name of the bits, X-on bits and X-off bits. Having seen it once, it really does slow transmission down. So we could set that for hardware with no problem. So now you've got to set the maximum transmission speed between the router and the modem. And iOS help, as you see when we put speed here, that's going to illustrate that this single command sets both the transmit and receive speeds, which makes sense. We want them to be the same. But what iOS help doesn't tell you is that this speed is set in BPS. So anytime you use iOS help and you don't see what the unit is, go out to cisco.com/universecd and double check it. Doesn't hurt a bit. Transport input. This dictates which protocols can be transmitted through this particular line. And you saw earlier on the access server configuration, I put transport input all, which is what we're going to put here. But you could tie it down to telnet. You could also tie it down to none, transport input none, if you so desired. Now, when it comes to the stop bits, those of you who use hyperterminal a lot are certainly familiar with having to set this as well. Different modem manufacturers will dictate different numbers of stop bits. And you shouldn't just put, 1 because it sounds good. You should check that documentation. We're going to put 2 here. That's a good idea to know the choices there. 1, 1.5, and 2. Why we need 1.5 in there, I don't know. Probably just the modem manufacturers being hard-headed. Now, finally, we can choose to have the modem make outgoing calls while accepting incoming calls, or just accept incoming calls. Let's look at the choices there. And you see we've got quite a few here. But here is dial-in. And here is in-out. So that's going to depend, of course, on what you want your modem to do. And there are also some other options there. Again, check that modem documentation and see what you should be running there. But that's really enough to get you started. We looked at the stop bits, we looked at transport input all, the login and password command, flow control, and speed. And those are the basics. That's really enough to get you started. All of that leading into the musical question, what is an initialization string? It's easier to define than to say. But basically what's being initialized are the communications simply between the router and the modem, and the string itself is a set of commands sent to modems before the call is actually placed. Again, they differ widely between manufacturers, so as far as these strings go, make sure to read your modem documentation carefully before you install that modem and then work with these strings. Because if you're lucky, you get to use auto configuration to set a modem up. Now, theory holds that you can connect the power cables and the phone cables and power the modem up and run the modem auto configure command right here to have the modem auto configured. And you're going to need to use the discovery type command there if you don't know what your modem type is. But if you do know what it is, and I hope you do, you could use the modem auto configure type command, and I believe, yeah, and then you're going to have to specify a name for the modem type. Now, generally things like this don't work terribly well, but Cisco routers, auto configuration works pretty well. And to configure a line or multiple lines for auto configuration, you do just exactly what I did there. It does seem to work a little better if you know what type it is, but it does work well either way. And that sounds great, but how exactly does that work? You may have used @ commands in the past, AT, and particularly if you've worked with Windows NT 4.0 for scheduling. You know, if you wanted to schedule a task, if you wanted the router to reload at 2 o'clock in the morning, or the NT server, I should say, at 2 o'clock in the morning, you could set an @ command and have it do so. And basically what happens here is that the router is going to transmit an AT initialization string at different baud rates until the modem sends it an OK message. And this looks a little like LMI AutoSense, right? I'm just going to keep sending the messages at different speeds until the remote device says, hey, I like that one. Now, once the router learns the desirable baud rate to use, it needs to know as much about the modem as it can learn, and it's going to send a series of @ commands. And it's intending to learn the modem's capabilities and record this information in the modem capabilities database, commonly referred to as modem cap. And this is fine, but again, if you know the model of the modem, you can configure the router to send a particular string to it with the modem auto configure type command that I showed you. And I would actually go with that if you know the name of it. If it doesn't work for some reason, you can always go with auto configure discovery. But while we're here talking about that, let's talk about that modem cap. And the modem capabilities database is a set of @ commands that will allow the router to auto configure many of the modems on the market today. And you can view this database, you can edit it. I'd be real careful about that. And we're going to do both of those right now. Unless you were experienced with @ commands and this kind of thing, I would steer clear of it if I could. But let's take a look at it. We'll go back out to the prompt and run a show modem cap, and this will actually show you the modem types that your router has @ commands for. And the last two there, 5 and Viva Viva, are ones I made up. And the top ones there, the top 9, I believe it's got default, and then it's configured for 8 more. So that's not bad. Those are some very popular brands there that we see. So these are the ones that this router has a modem cap database entry for, and there is a default as well that we could configure. So to see specific information regarding any of these particular types, you run show modem cap followed by the modem type itself. So we could use show modem cap USR courier. And let's see what we've got there. Quite a mouthful there. One vital attribute to look for is the attribute that locks the DTE speed. This is one that I've changed on more than one router because Cisco recommends that you set this attribute to prevent the modem from communicating at the speed of the phone line, and rather you want it to communicate at the speed configured between it and the access server or the router. And the fun part is actually trying to set it. Here it's pretty self-explanatory, but again, it's not always that simple. So check that check that modem documentation. Now, an excellent command to have it ready to go if you have to talk to tech support for some reason regarding your modem is modem cap edit. they may ask you to change or edit the contents of this database. So let's try that. Modem cap edit. And I think it's going to ask us for a type here. Need to be in config mode. Modem cap edit. And it's going to ask you, it doesn't give you the list, unfortunately. Courier. Got to go with that underscore there. And let's see what else we need there. Oh yeah, I wanted to show you iOS help. As you can see, you can change a lot of commands here and a lot of modem cap entries. And you also saw they're not always the most intuitive. I mean, we've got some codes here. I mean, carrier detect is the AND side followed by C1. Only if you work with these a great deal are you going to know what that means just by looking at or what to change it to. So again, I would be very, very careful about changing modem cap settings. I don't think I've ever had to do that. And I've worked with quite a few modems. But for exam purposes and production network purposes, it's good to know. If there's such a thing as hardcore modem configuration, this is pretty much as deep as it gets. And if you make these changes, of course, show modem cap and show run will both change your save your changes. And that's really about it for the modem capabilities database. And there's always something else to learn on these babies, isn't it? And speaking of that kind of thing, I'm going to wrap this up with a quick discussion of chat scripts. Chat scripts, at their base definition, they are a text string that defines how the DTE-DCE interaction is going to take place. What's going to happen here between the modem and the router. Now, I've put a couple of common tasks up here that chat scripts can perform, but they can do a lot more than this. You just have to draw the line somewhere. If you go out to the net and just put in chat script in Google or any other search engine you care to use, it's just amazing. I mean, people who use modems a lot, and of course other networking devices have written scripts that practically put us out of a job. It's really incredible. And the actual creation of a chat script for anything is beyond the scope of the exam. It's a real good idea to know a couple basic things they do and, of course, what they are. And if you're curious about chat scripts for Cisco routers, if you put the term modem chat script into Google, I don't know exactly what you're going to get right off the bat with other search engines, but put that into Google, and actually one of the first matches you'll get will be a Cisco chat script guide. Some interesting reading. Now, before you use them in your network, there are a couple of limiting factors you should know about chat scripts and Cisco routers. You can only use them with Cisco routers if you're using the auxiliary port. If you're doing work with the lines for dial-in, it's not gonna work. And outbound chat scripts are not supported on lines configured for incoming calls only. It should say port. Again, I would not be surprised if people have gotten around that first one. I think they have. But the official word is that Cisco routers allow chat scripts to be configured only on the auxiliary port. And that's going to wrap it up as far as chat scripts go. But like I said, they do so much more than what we've talked about here. And when it comes down to study for modems on this one, like I said, there's just some plain memorization you're going to have to do. There are some commands that we looked at in the second half of this video that you can certainly run on your home lab and, you know, keep using iOS help, keep trying different things. If you have a modem you want to connect to the router, that's fine. I don't think it necessary to go out and buy one. But if you want to, again, I never discourage anybody from doing a little extra. So have those line types in mind, you know, the pin types, have those in mind when you're ready to take the exam. The modem standards, that kind of thing, reverse telnet, we actually saw that in action, and how the IP host table worked with that to configure it. The line numbering, where TCP port, the base is 2000, and then you add the line number, that's always good to keep in mind. That knowledge will come in handy in production networks. And just be familiar with the show commands that we looked at here, and I think you'll be more than fine. So having said all that, I appreciate your time, and I'll see you on the next video.